All right, now we're going to cover about how all this relates to polyatomic ions. All right, so we're going to start with a basic polyatomic ion. Okay, let's first say that the are built with covalent bonds. And they collectively, this is how. This is how they hold a collective charge. And we talked about this before, that you have the group of atoms, and the entire group of atoms has a usually negative charge to it. This is how they're built. This is why they're able to maintain a collective charge. Or we'll demonstrate that here. So the first example we're going to give is we're going to do hydroxide. Okay, so we're going to follow pretty much the same rules. Okay, how many electrons does oxygen have? Or more important, how many electrons total are there? Total electrons. Okay, oxygen's going to have 6. Hydrogen has 1. But this guy right there is an extra electron. That's how we get negative charges, right? Okay, so the total electrons is going to equal 8. Yeah? Okay, now, how many bonds does oxygen like? 2 bonds. Hydrogen likes... Well, there's a problem here. Because if hydrogen only likes 1 bond, we're going to start with OH. And there you go. We're pretty much done because hydrogen can't make any more bonds. Right? So there's 2 bonds. We're going to take 8 electrons. We're going to subtract the 2 electrons. And that leaves us with 6 electrons, right? Well, if we distribute those 6 electrons, well, oxygen's happy now, isn't it? It has 8 electrons. Okay, it would normally have that second bond in order to get happy, to have that other connection, to make to share one of its 6 electrons, okay, with another element. But if it doesn't have to, but it's got a spare electron hanging out, it'll fill in, and then this whole thing has a negative charge to it. Now, if you look at this, which electron was the extra one? You can't tell, right? It could be any one of them. That's why it's a collective charge. It could be any one of the electrons. Yeah? So there isn't... If we could distinguish which electron it was, then this whole thing be an ion. It would be that part of it would have a positive or negative charge. Because we can't distinguish the electron, it's got... The whole thing has a collective charge of -1. Yeah? Okay. Let's do a new one. Okay, so this time we're going to try PO4 3-. All right, there's going to be a lot more electrons for this one. Okay, so how many electrons total do we have? We've got a phosphorus. Okay, phosphorus is going to give us 5 electrons because it's right below nitrogen. We have 4 oxygens. Okay, and plus 3 extra charge electrons. And that gives us a total of 32 electrons. All right, phosphorus likes how many bonds? It is in the nitrogen group, and so it likes how many bonds?
3.
3 bonds. I saw that, Riley. Okay, oxygen likes how many bonds? 2. Okay, but there's 4 of them, so oxygen is going to give us 2 bonds per oxygen. Is going to give us 8 bonds. Okay, and that's all we got. So we know that phosphorus, well, there's 4 of them there, right? There's 4 oxygens. Okay, and phosphorus only makes 3 bonds, though. Well, we can do... Okay, but this says 4. So we've got to have a 4th one. Okay, phosphorus kind of looks overloaded, though, doesn't it? But if it doesn't bond with it anymore, if it doesn't have any extra electrons, it's okay, right? Phosphorus has its 8. Yeah? Okay, well, that's 8. I'm sorry, there's 4 electrons, 4 bonds times 2 electrons. And we will subtract 8 electrons from that, and we'll get 24. Okay. And now, check this out. How many oxygens do we have? We have 4 oxygens. Each oxygen if I made all the oxygens the same, this would have how many electrons around it? Lone pairs. 6. 4 times 6 is 24. Oh, that doesn't go there. Oops.
Are you missing one on the top one?
Yes. All right, and then this whole thing has a negative 3 charge. It's got 3 extra electrons. Where is it? Where are they? They're tucked in there somewhere. It's some random, it could be anywhere in there. It just somehow acquired 3 extra electrons to make this phosphate. And this was hydroxide. Okay, and this is phosphate. Yeah? Now, this is just a diagram, and we'll do one more, and then we'll pause for the day. But something I want you to think of is this is just how we're writing them on paper. Do you think it's really flat in real life? No. Okay, and if it wasn't flat in real life, and you've got all these electrons, all these negatively charged particles swarming around each oxygen, okay, do you think they're going to want to hang out with each other? No. What do you think they'll do? disappear. Well, they don't go away. Okay. Go to other atoms? Nope, they stick there. There's still this phosphate ion. Okay. Think of the person that you find most repulsive in this world. Okay. Mateen, don't point any fingers. Because everyone will be pointing back at... No, never mind. Okay, but you are tethered to that person. But you are tethered to that person. What would you do with that tether? Okay, well, aside from cutting the tether, you're missing the point. You would be at the full length of that tether, right? You would be as far as you can. Okay, now, what if you were tethered, okay, to, what if you were tethered to multiple people in the class that you were repulsed by? Okay. All of those tethers would be as tight as they go, right? Everyone trying to be getting far away from each other as possible, but they're still stuck. Okay. That's what's going on with our oxygens. These oxygens do not like each other. They've got full shells of electrons. All that negativity on the outside is just repulsive, but they're all stuck to the phosphate in the middle, to the phosphorus in the middle, and they're going to try and get away from each other as much as possible. Now, if you think in 2 dimensions, it's all just going to be right 90-degree right angles, because that's as far as you can get in 2 dimensions. But if you can go in 3 dimensions, you can get just a little bit further. Okay? And our molecules start making shapes because of this concept. Okay? And that's what we'll get into next time on Nova. No, on next time when we lecture. So we have one more example. You guys don't watch Nova? PBS science show? Fantastic.
I watch PBS Kids.
It's not on PBS Kids. All right. Okay. We're actually going to do 2 more. Sorry, 2 more. Because they're cool. Okay, the next one. Pay attention. This is the next one, and then I also want to do what else did I want to do? I want to do okay. So we're going to do these 2. How many electrons total? This is tricky. Okay, nitrogen has 5. Each hydrogen has 4. But that's a plus charge. How do we get a plus charge? By losing an electron. We have 1 less electron to deal with. Okay, so that's a total of 8 electrons. There's a total of 8 electrons. We have 4 hydrogens. Each hydrogen needs a bond. And the whole thing has a plus charge. Two, 4, 6, 8 electrons. Each hydrogen's happy. Nitrogen has its 8. All right. Last one. Sulfur. Sulfur is in the oxygen group. So we're going to get 6 electrons from sulfur. Oxygen. 3 times 6 is going to give us 18 electrons from oxygen. That's a total of 24 electrons. Okay, sulfur is again, it's in the oxygen group, so it likes to make 2 bonds. Each oxygen likes to make 2 bonds. There's 3 of them, so that we're expecting a total of 6 bonds. Okay. But we have 2 extra electrons to deal with, right? So, sulfur, oxygen, oxygen, oxygen. All right, so there's 6 right there. Minus 6 is 20. And so we've all got our bonds. We're going to start throwing our electrons out there. So sulfur needs a pair. Oxygen, oxygen. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And we're done, yeah? Okay, and that still has this lone pair here in the middle. Okay, and that's how we do polyatomic ions. This is how we do it. Don't.